Let's discuss a question from strength of materials. Basically, a shear force diagram is given, which is a straight line from A to B, and we need to find out the bending moment diagram. So before going to the problem, actually, you should understand that some basic rules about SFD and BMD. The slope of the bending moment at a point. Okay, slope of a bending moment diagram at a point is equal to the value of SF, value of the shear force at that point. So this is a basic rule, okay, which you can always use. You have to use actually when one of the diagram is given and the other is asked. So this comes from the fact that dm by dx is f. So this is at any point the slope, which is nothing but dm by dx, is equal to the value of the shear force. So going by this rule, so now out of these four we need to select which one is the best. So what we will do is we'll see the slope of the bending moment. The slope of the bending moment diagram should be such that it's a straight line at all points. Now if you look at A and D, the slope is always, straight line slope is always constant. So going by that, the SFD should be a constant value. This means the identical shear force diagram for part A would be somewhere like this. Slope is always constant. The shear force has to be like this, but that is not the case. So A and D are ruled out because the slope of A and D, both the curves in A and D are straight lines, so the slope of the straight line will be a constant. So the shear force diagram should look like a rectangle, which is not the case. So A and D are ruled out. Coming to B and D, now the slope should be such that it should be always increasing, okay, from B to A. So at B, if you look at B, the slope of the bending moment diagram at B, if you take a slope here, the slope is 0 at B, okay, and at D the slope has some positive value, right? If you take a tangent here, how do you find out the slope of a curve? So it's a tangent and see how much angle it makes with the x-axis. So if I take a tangent at B, the slope is 0. If I take a tangent at D, the slope is a positive value. So do shear force represents that slope at B, slope at B. So the value, basically, let's go like this. The value at B, the shear force value at B is 0, and at A it is some positive value. So now my slope should be such that at B it should be 0 and at A should be positive. So at B it is 0 and at A is positive. But if I look at this curve, at B it is positive, whereas at A it is 0. So the corresponding diagram for the option should satisfy this. That is, at B the slope should be 0 and at A the slope should be positive, and that happens only in option B. So this simple fact can lead you in solving problems. You need not, from SFD you need not guess the loading diagram, and from there you are drawing the bending moment diagram. That is all time waste. You just have to check the slopes. So slope of bending moment diagram you have to check, and that should be the value of the shear force diagram. So from this we get that shear force diagram at B is 0, the value is 0. Shear force diagram A should be positive, is some positive value. So from this what you mean is that the bending moment at B should be the slope of the bending moment at B should be 0, and the slope of the bending moment at left hand should be positive, and that happens only at B. So B is the answer. D is wrong because at B the slope should be 0, because that is the value of shear force at B, and the value of shear force at B is 0. So the slope of the bending moment diagram at B also has to be 0. But that is not the case. So only B satisfies this. Answer is B. Thank you.